This video gives some idea of a typical year in the John Innes wheat field trials. The trials focused on are part of the Simon Griffiths Group and form part of the BBSRC Wheat Improvement Strategic Programme. They are in no way a comprehensive list of all the characteristics that could be studied, but instead are a skeleton set of routinely studied traits that we focus on. Okay, it's October, and that means the start of the field trial season where we do our drilling. And what we're drilling here are Hagee 90 1 metre beds. Each one of these cups that you can see will produce a single 1 metre row. And 3 of those 1 metre rows, offset to give us accuracy, will go to create a 1 metre bed, which will give us enough seed for replication in the future, somewhere in the region of ½ a kilo to a kilo of seed. And will also give us a chance to give us a first idea, an initial look at some of the traits that these genotypes, how they're performing. This is the John Innes Crop Genetics Field Trials site. We're at Church Farm, Bordborough, and we run this as part of a commercial farm in a larger scale. This is the first look at these this year. It's very much at the establishment stage of the field trials, and we're going to look today at some of the growth stages, things that we're looking for, things that might be going wrong, and what's happened so far. The plants have been sown around 3rd week of September through to about the 1st week of November, and growing conditions have been pretty standard so far this autumn. It's had cold spells, it's had wet spells, but all in all a fairly average year. What I've got in front of me here are 2 plants of a typical stage which we are looking at the moment, and we're looking at about growth stage 12, 13, just simply 1 tiller and three leaves unfolded on that tiller. So on a day such as today, about 8 hours daylight we're getting at the moment, right in the middle of the vernalisation period, only around 4 degrees Celsius. These plants are not moving very much. What we are looking for though is establishment, how well the drills have come up, how full they are. From a disease point of view, not much is going on at the moment, but what we do want to keep an eye on is exotic material that we may have in this field from other countries which will not have resistance to diseases. Also, people may have trials which they want particular diseases in the springtime, and then from that point of view you want to make sure that we're really keeping down other diseases that they don't want to see. So it's been an interesting winter, relatively mild, very wet, and of course that means that the diseases are going to be pretty rife over the next coming few weeks and months. One of the issues of a mild winter is if you've got quite exotic spring-like material that was sown in the autumn, it starts to get a little bit of extension on, it starts to put a lot of leaf material on over these mild winter months. Compared to what you can see around more UK-based winter material. What could happen is if we now get a little burst of cold weather, this material is going to be very tender and it's going to suffer. We're looking for early signs of disease, and typically the earliest one we see here today is Septoria, shown by the black dots on the lower leaves. We will spray and be a lot more protective than the average farmer because we want to keep diseases really down. So by this point we will have sprayed for wheat bulb fly, we will be spraying for Septoria and the rusts very soon. March the 20th. We've come indoors out of the wind. What I want to show today was a few of the ranges of the growth stages that we have in the field trials at the moment. We've reached this stage in the spring in the UK where it's about 12 hours daylight, 12 hours nighttime. So just wanted to explain that, as we've mentioned before, we don't have plants all at the same stage as in the field trials. We have a range of them, which makes maintenance and husbandry very difficult for the field trials staff. And just to look at what we've got plants here. These were the late sown plants, and these are still way down at growth stage 12, 13, and that goes all the way up to potentially about growth stage 22 with a couple of tillers now forming. We are getting very close to our first trait, which is that first node detectable, growth stage 31, and we're now starting to have a little think about that with these plants that are starting to elongate, stem erection. So what we're going to be doing now over the next few days is looking out for this growth stage 31. We're going to be feeling for that first node detectable, and after that occurs, looking for the terminal spikelet of the ear and recording the date that this occurs, and this will tell us something about the development of the plant at this very early stage.
The first thing we measure is the terminal spikelet stage. It is a starting point for the floret development. It is a lot of work, but it is worth it. The more we know about floret development, the more likely we are to increase yield potential.
The phenotype we're going to explain today and to have a look at is ear emergence, heading time. Typically, the phenotype of heading is done through maybe 2 visits per week. In that time, you come into the field, you go through your entire plots, and you are looking for things that are going to come up flowering within the next 2 days. You're looking at plots which may have flowered or come to the heading time 2 days previous, and you're trying to create a picture of how the trial is working. So what I thought I'd do is, in the space of about 4 or 5 plots here, a little selection of plots, I'll show you how I would be scoring them at any visit. We'll look at this plot first. This plot nowhere quite near ear emergence yet. The ear is still well down in the boot, and this one I would simply walk past on a visit and wait for a later date. So to look at these 2 plots, we've already decided that this one is nowhere near ready to score. It's still a few days off. However, beside here we have one which is indeed actually showing some ears which are at the correct stage. This one nicely 50% emerged from the flag leaf, but a quick 2-second scan over the plot tells you that not enough of those ears are at that stage. So I would leave this plot, I wouldn't score it today. I would forward score it maybe 1 day, and in 2-3 days time when I revisit, I would actually have that confirmed. I would imagine that having walked through this plot 3 days ago, I would have forward scored this plot 1 day. And coming back 3 days later, I think suspicions are confirmed by saying that if I look at these ears, they're all mostly left the flag leaf now, some by a little way. And I would be happy to say that that was 2 days previous at 50% ear emergence generally for the plot. After ear emergence, which we score, the next stage would be anthesis, and this is where the pollen is actually coming out of the anthers. The pollination is actually occurring, and to score that, you're looking for nice fresh anthers emerging, probably about 2/3 of the way up the ear. A quick scan over the plot shows you that some are just beginning
Some have been going a day or so, some may have been going for a couple of days, but generally anthesis is pretty much occurring in this plot right now. Anthesis are slightly trickier trait to score. It's a little bit weather dependent in that if it rains you tend to get the anthers knocked off and it's quite hard to score it. But if you're looking for the absolute date of pollination, this is what you'd be looking at.
We're doing height measurements in the field today. This is the height of the mature crop, and we're going to measure every plot that's in the trial. And to do that, as we come from this plot and I walk forward ready to go on to the next plot, my eyes are already focusing onto the central area of this 6 metre plot, and I'm going to pick an ear out from distance that I want to measure, which to me is going to satisfy that that's the average height of the crop. So as I walk towards it, I'm looking into the centre, I've got my ruler, and I'm going to go down and I'm going to find that ear. I'm going to call out 76 centimetres, and I'll have someone beside me recording that or onto a handheld device. Another way to collect your data for height measurements within a plot is to create and to gather more than one measurement. And so for that, we would again be working down the centre of the plot, and this time going in, taking random measurements, depending on how much your time you've got, what your capabilities are, 3, 5, maybe 10 measurements. Going in and collecting the data, 74 centimetres, 75, 75, and relaying that to somebody's scoring and then creating a mean of your plot. So another way to collect your height data from a plot would be to use a bar, and resting it on the plot, you would lower it until you see a certain amount of ears just poking above it, but equally plenty that are below it. And you would do that until you found a measure that you were happy with, drop your ruler in, and you're coming out at 76 centimetres with the bar sitting there. Right, just a quick word dealing with varieties with awns. Do make sure that you record just to the tip of the spikelet and disregard the awns. On this one, for example, you've got 83 centimetres without awns. Stick the awn on that and you're up to well over 87 centimetres. So the height of a plant without awns. Between anthesis and harvest, we may experience lodging in a crop. Lodging is the ability or the loss of ability for a plant to stand up. Here we can see a crop perfectly standing up, that's fine. But next door to it, we've got one that's gone down completely, almost flat. And this is happening because of nitrogen uptake, it's because of yield, straw strength, root strength, storm damage, winds, rain. Many things can lead to lodging, but there's definitely an occurrence where some genotypes are a lot more resistant to it than others. And what we'll do is try and ascertain some way of gauging this. What we turn to is the UPOV characteristics. A straight up crop, perfectly standing, as this plot here is doing, we would call this a 1. Next door to it, we have something that's almost flat completely, but not quite. Because of this, it's lifted slightly, we'll give that a 7. One more plot over, 45 degrees, and we'll give that a 5. And then somewhere between the 45 degrees and upright, we would give a 3. Today we're out here to take some tiller samples from this crop. It's the Buster Charger double haploid population, and we're about 2 or 3 days pre-harvest here at the moment, so it's a good time to come in here. The crop is fully mature, and the labels have been added to the plots first using the field book, so that we make sure we identify every plot properly. And what we're going to do is we're just going to simply go into the plot, grab 3 or 4 good handfuls of tillers, 3 or 4 plants, bundle them up together and collect them up later.
what that will give us is at least 10 ears that we can work with. We can study internode lengths, we can study ear characteristics, we can study grain shape, grain size, grain number. So this little bundle will give us a lot of indication as to why this plot is yielding how it does.